So let's just talk a little bit about the heart and the cardiovascular system just to get our mind on that subject. Here's the cardiovascular system right here, and what are the features of the cardiovascular system? What organs do we find in the cardiovascular system? Find the heart. What else? We have blood vessels, and what's located within those blood vessels? Blood. Okay. And if you want to talk about what each of those does, the heart can be considered a pump. And every time it contracts, it creates pressure. And the principles of pressure and blood pressure and how that results in blood flow, that's all about that panopto. Okay, and it's physics, it's information that I want you guys to know. So the heart is a pump, and every time it contracts, it creates pressure. What's the point of that pressure? Why do we want to create pressure within the cardiovascular system? What does that accomplish? It propels blood through the blood vessels. So we have the heart that's a pump. We have these blood vessels, which is basically a closed set of tubes, and then we have a liquid flowing through it. So the heart pumps, creates pressure, and that propels the blood through this closed set of tubes. And these blood vessels reach pretty much every area of the body. There's a few tissues that are avascular, but they get close to them. So that's what's going on. A pump, fluid, and a closed set of tubes. So if I had to describe what the cardiovascular system does with all of this, I would say that it's a pickup and delivery system. It picks things up and it delivers those things to other places. What kind of things is the cardiovascular system picking up and delivering to other places in the body?
Oxygen.
We pick up oxygen. Where do we pick up oxygen at? We pick up oxygen at the lungs. That oxygen travels throughout the cardiovascular system, throughout the blood vessels. And where does that oxygen get delivered? To the cells of the body, which need it for 160 cellular respiration. Okay? What are some other things that we pick up and deliver that we've already talked about in this class? What about?
White blood cells.
Where do we pick up white blood cells from? The red bone marrow and the thymus and other places like that. And where do we deliver them? To the lymphoid organs, wherever they're going to go. What about related to the digestive system?
Absorbed.
We pick up nutrients. Where do we pick up nutrients at? The small intestine. Where do we take those? Different places in the body, the different cells of the body. What about related to the endocrine system? What do we pick up? We pick up hormones from these endocrine glands and we take them to their target cells. All this kind of stuff. We pick up old red blood cells and we take them to the spleen. We pick up heat from the cells and we distribute it throughout the body. So basically the blood, the liquid portion, the blood I should say, is the medium that these materials are going to travel through. I didn't mention that. So they're all going to be delivered via the blood traveling through the blood vessels with the pressure that's created by the heart. Now we do have to review a little bit of blood vessels just so you can kind of understand the schematics here. But there's three major types of blood vessels. One of those are arteries. And arteries carry blood away from the heart. And as such, you can see that arteries branch and they become smaller and smaller and smaller. Here's the heart right here. And what does it say? These are the different types of arteries. What are the largest arteries in the body? Aorta. Okay. And so here's the heart, and specifically here's the aorta. And what does the aorta do? It branches into these smaller arteries and then into what we call arterioles. So the aorta comes out and it branches and it goes down through the thoracic cavity, the abdominal cavity, and it branches and branches and branches to all these arteries, which branch and form arterioles until eventually you get down to this small level right there called the capillaries, which is the second type of blood vessels. And what happens at the capillaries? That's where actual exchange of materials occurs. So here's an arteriole, and an arteriole branches, and it forms this capillary bed. Now these capillaries are super thin. They're only one cell layer thick, and the reason that's the case is because it allows materials to move in between the capillaries and the interstitial fluid here. So this is where the actual exchange of materials occurs. This is where we pick up substances, and this is where we deliver substances at the level of the capillary bed. Then what happens? Those capillaries converge, and they merge into the venous system. So the venous system, veins carry blood towards the heart. And as they move towards the heart, they converge together like tributaries in a river, and they form larger and larger rivers, until eventually you get to the largest veins of the body, which are the vena cava. All these veins come together, they're collecting blood, they're coming towards the heart, and we have two vena cava. What's this part of the vena cava right there called? That's the superior vena cava, and this one right here that collects blood from basically all of the lower part of the body is called the inferior vena cava. This is a nice diagram of the cardiovascular system, and you guys should understand pretty much everything that's on here. Okay, you guys should understand this really well. This is a frontal section of the heart, anterior view. And what you can see with the heart is that the heart is divided into right and left sides. This is the right side of the heart. This is the left side of the heart. How many total chambers do we find in the right and left sides of the heart? There's 4 chambers. Okay? So the right side has, what's this chamber generically called up there? That's an atrium. And what's the chamber below it?
Ventricle.
That's a ventricle. So we have the right atrium and the right ventricle. Then over here, on the left side of the heart, what's this chamber? Left atrium and the left ventricle. And something that I want to point out here is that the right side of the heart, there's also two different circulatory systems that are part of the cardiovascular system. There's the pulmonary circuit and there's the systemic circuit. And all of this is connected, but we kind of have 2 different main places where these blood vessels go. The right side of the heart is going to send blood up to the pulmonary circuit, up to the lungs. The left side of the heart is going to send blood out the aorta into what we call the systemic circuit. And systemic just means widespread. Okay? All right. Now, whenever you see blood vessels and they're colored blue, that means that the blood within those blood vessels is oxygen poor and high in CO2. Whenever you see blood that's colored red, that means it's high in oxygen and low in CO2. So here we have the systemic circulation. We have this blood that's high in oxygen and low in CO2. That blood is delivered to the capillaries of the body. And what happens to that oxygen? We drop it off for cellular respiration. What's a byproduct of cellular respiration that we need to pick up? CO2. So we're dropping off oxygen, picking up CO2. So the blood that enters the venous system here, we dropped off the oxygen, so it's oxygen poor. We picked up CO2, so it's high in CO2. Is this blood any good to us like this? It's not. So we send that blood to the right side of the heart, it goes into the right atrium, down to the right ventricle, and the right ventricle sends it up to the pulmonary circuit. What happens when it gets up here to the pulmonary capillaries? What do we do? What do we do with this, all this CO2 that's in there? We drop it off and exhale it. What do we do about the poor oxygen supply? Oxygen moves from the lungs into the pulmonary capillaries. So now the blood coming out of the pulmonary capillaries is high in oxygen, low in CO2. This is good. This is what we want. So now that blood returns to the left side of the heart, goes in the left atrium, into the left ventricle, gets shot out the aorta, and now this, good blood right here is able to go to all the systemic tissues and again drop off oxygen, pick up CO2. Then it goes back to the right side. Then it goes up, regenerates itself, and over and over and over. Now I do want to point out one thing. Remember, arteries take blood away from the heart. So all of these arteries that come out of the left side of the heart, the aorta and all of its branches, these have high levels of oxygen in it. Veins carry blood back toward the heart. And veins in the systemic circulation have low oxygen. Now it's a little different up here in the pulmonary circuit. Going from the right ventricle up here, we have this vessel that takes blood up to the lungs. What do we call this vessel here? Pulmonary artery. It's an artery, but it's colored blue. This is the only artery in the body to carry deoxygenated blood, blood that's low in oxygen. All the other arteries in the body have high oxygen. What's this vein right here that's bringing blood back towards the heart? It's the pulmonary vein. This is the only vein in the body to carry oxygenated blood.
Yeah, with that convention.
Well, because it's taking it away.
Well, it's all definitions, arteries away, veins toward. Okay. This stuff I'll deal with later. So just see if there's anything else I want to pick up here. So this right here represents the pathway of blood flow through the heart. And we're starting in the right atrium here, and you can follow blood, and it goes, all throughout this system. This is the first thing that we're going to do on, Wednesday? On Monday. We're going to go through this, and I'm going to call on you guys, and you guys are going to tell me all about the blood that's in these chambers, where it goes, the different valves it goes through, all that kind of stuff. Okay, so this is your, I'm going to be asking you about this first thing next class. And one thing that I want to point out is that when blood goes through the heart, it's not like blood goes from the left atrium to the left ventricle up to the circulation, then the right atrium to the right ventricle. It's not like it goes doot, 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 doot. What happens is that the events on the right side of the heart occur simultaneously with the events on the left side of the heart. So this is one heartbeat right here, love dub, love dub. And with each heartbeat, blood moves from the right atrium and in the left atrium down to the right ventricle and the left ventricle. The ventricles fill up with blood, and the ventricles simultaneously contract and send blood out their respective arteries. So with each heartbeat, blood goes from the right atrium, with each heartbeat, blood goes from the atria to the ventricles. The ventricles contract, and they go out the aorta and the pulmonary artery simultaneously. Okay. You guys want to talk about some basic anatomy, or do you guys just want to call it good?
Let's talk about it.
Let's talk about it.
Go for it.
Okay, let's talk about the location of the heart, where it's at, all that kind of stuff. What cavity is the heart contained within? That's the pericardial cavity. Okay, so the heart's right there. This cavity right above it is called the superior mediastinum. Anybody remember anything about that? What's going on here with the superior mediastinum? What do we find in that empty space? It's actually not empty. How about the esophagus passes through there? Trachea passes through there. All the major blood vessels that exit and enter the heart pass through the superior mediastinum. The aorta, the superior vena cava. So we find a lot of vesselage in that superior mediastinum. I'll talk about this layer, but these are the layers of the heart. Not surprisingly, well, first of all, there's a pericardial sac that wraps around the heart, and then this is the heart wall right here. And what's this big, thick layer there? What kind of tissue do we find in there? We find muscle. What type of muscle do we find there? Cardiac muscle. Cardiac muscle. This is the heart right here, and I like this because this has the pericardial cavity around it. You can cut open, but this is the pericardial sac that's around it. And the pig hearts that we have, the pericardial sac isn't in there, but when we do the respiratory system, we have the lungs, they're basically from a sheep, and we have the lungs, and then the heart is still attached there. And the pericardial sac is either around it fully or it's cut, but you can still see it. So we'll get a feel for that a little bit later. Is the heart pretty well protected? It is. It's got the thoracic cage around it, the sternum right here, the ribs, the vertebra in the back. About 2/3 of the mass, if this is the mid-sagittal line, about 2/3 of the mass is to the left side there. It rests on this feature right there, which is the diaphragm. So the heart has a base and it has an apex. What does apex mean? It means point or top. So the apex, which you would think, if you're thinking of a mountain, the apex is the top. Well, the apex of the heart is actually down here, and it kind of points down left. Okay, like so. So that's the apex of the heart. And if you press your fingers in between your 5th and 6th ribs, right below the left nipple, then you can feel the apex of the heart, because every time the heart beats, that apex has an apical impulse associated with it. So where does that make the base? If you were to cut off all these vessels here, this is the base of the heart, and then that's the apex right there. A lot of good external features that you'll need to identify. I can go through these, I'll go through these later. But basically this is an anterior view, this is a posterior view. And the anterior view is you'll see this on the pig hearts, it's just a lot cleaner. Okay, there's not as much going on. This is the posterior view, and all these major vessels kind of enter and exit on the back side of the heart. So there's a lot more vessels, and there's all this connected tissue there. It's just not as clean looking. Yeah, this is a nice artery right there. The anterior interventricular artery. Why is it called the anterior? Because it's on the front. Interventricular, what does that mean? Between the ventricles. And so it's not physically separating the ventricles, but it's a good identification marker because superficially it represents the boundary between the ventricles. So what ventricle would we find right here? This is the anterior interventricular. It's between the ventricles. So what one would you find here?
Posterior.
That's the right ventricle.